Langchain text splitters Python code text splitter. Langchain text splitters Python code text splitter. A text splitter that splits text based on Python code blocks. For instance, it can be used in situations where you have a large document containing code and text interspersed, and you need to split it into smaller chunks for further processing. This splitter is particularly useful when working with code documentation or code examples within text. Component 1. Python code text splitter. This class is responsible for splitting text based on Python code blocks. It uses a regular expression pattern to identify code blocks and divide the text accordingly. Component 2. Split text. This method splits text into chunks, taking into account the Python code blocks. It uses the split text method internally to handle the actual splitting process. Split text. This internal method implements the core logic for splitting text based on Python code blocks. It utilizes a regular expression pattern to locate code blocks and divide the text into chunks. Utilizes a regular expression pattern to identify Python code blocks and split the text accordingly. This pattern is designed to recognize the syntax of Python code and accurately extract blocks of code from the text. For example, it will identify blocks of code enclosed within triple backticks or indented code sections, ensuring that the code is split correctly without disruption. Facilitates the processing of text containing Python code by dividing it into manageable chunks. This allows for easier analysis, processing, and understanding of code-heavy documents. For example, when working with code repositories, this splitter can be used to break down large files containing code and comments into smaller, more manageable chunks. This makes it easier to analyze the code, extract relevant information, or even translate it into different programming languages. Preserves code integrity by ensuring code blocks are not split. This is important for maintaining the functionality and correctness of the code. For example, if a code block is split in the middle, it can cause syntax errors or break the code's functionality. By preserving code integrity, the Python code text splitter ensures that the code remains functional and can be executed without issues. Enhances readability and processing efficiency by splitting text based on logical code boundaries. By separating code blocks from surrounding text, it makes the text easier to read and understand. It also enables more efficient processing, as the code blocks can be handled separately from the text. This allows for more targeted analysis and processing of the code, improving the overall efficiency of the process. Handling complex code structures that might contain multiple nested code blocks. For example, dealing with nested functions or classes can be challenging, as the splitter needs to ensure that the code blocks are correctly identified and split without losing any part of the nested structure. This requires careful handling of the regular expression pattern to avoid misinterpreting code blocks. Maintaining context when splitting text containing code that spans multiple lines. When code spans multiple lines, the splitter needs to ensure that the context of the code is preserved across the split chunks. This requires preserving the indentation and other formatting elements that contribute to the code's context. For example, when splitting a function definition that spans multiple lines, the splitter needs to ensure that all the lines belonging to that function are kept together in a single chunk to maintain the function's context. A comprehensive description of the architectural design and steps involved in the LangChain text splitter using spaCy library. The LangChain text splitter using spaCy generally adheres to the following steps. 1. Initialize sparse language model. Load the desired spaCy model, such as NCore WebSM, for English language processing. 2. Process the input text. Pass the input text document to the loaded Spatie model for analysis. 3. Sentence segmentation. Utilize SPA-size sentence segmentation capabilities to break down the text into individual sentences. 4. Tokenization. Tokenize each sentence into individual words or tokens, using SPA-size tokenization functionality. 5. Splitting based on criteria. Apply the configured splitting criteria. For example, splitting based on the number of sentences, words, or characters. 6. Output. Return a list of text chunks, each containing a coherent portion of the original document. Role. An explanation of the role and significance of the LangChain text splitter using Spatie library in various natural language processing (NLP) pipelines. The LangChain text splitter using Spatie acts as a vital component in numerous NLP pipelines. It facilitates the efficient processing of extensive textual datasets by breaking them down into manageable units, simplifying downstream tasks like question answering, summarization, or sentiment analysis. Advantages. Enhanced coherence. SPA-size NLP capabilities ensure that the split segments maintain semantic coherence, resulting in meaningful and logically connected text chunks. Flexibility. Supports various splitting criteria, such as sentence count, word count, character count, or custom splitting logic, allowing for adaptability to different requirements and text structures. Scalability. Handles large text documents efficiently, making it suitable for real-world NLP applications that involve processing extensive datasets. Challenges. Resource dependency. Requires SPA-size language models, which may require installation and resource allocation, adding a dependency on external resources. Potential ambiguity. Sentence segmentation and tokenization might not always capture the nuances of natural language, leading to occasional inconsistencies in splitting, especially in cases of complex or ambiguous sentence structures. Language support. The effectiveness of SPA-size models might vary across different languages, posing a challenge for multilingual NLP applications that require support for multiple languages. LangChain text splitters. Sentence transformers overview. Definition. Detailed definition of the variable goes here. Components are the building blocks that make up the variable. Component 1. LangChain text splitter is a component of the LangChain library that splits text into smaller chunks. It is used to make text data more manageable for tasks like question answering and summarization. Component 2. Sentence transformers are a type of neural network that is used to generate embeddings of text. These embeddings are used to calculate the similarity between sentences and are often used in natural language processing (NLP) tasks like text classification and question answering. Architecture. Description of the architecture supporting the variable. Sentence transformers are used to generate embeddings of text, and these embeddings are used to calculate the similarity between sentences. This similarity is used to split the text into chunks that are roughly the same length. For example, a document about the history of artificial intelligence could be split into chunks based on the similarity of the sentences in each chunk. This would result in chunks that are about the same length and that are semantically related. Role. Explanation of the variable's role in the system. This text splitter uses sentence transformers to split the text into chunks of similar length. This is helpful for tasks like question answering and summarization, where the text needs to be broken down into smaller manageable units. For example, a question answering system might use this text splitter to break down a long document into smaller chunks that can be more easily searched for answers. Advantages. More consistent chunk sizes means that the chunks of text are all roughly the same length. This can be helpful for tasks that require a consistent amount of text to be processed at a time. Better for semantic similarity-based splitting means that the chunks of text are more likely to be semantically related. This can be helpful for tasks that require a deep understanding of the text. Challenges. Sentence transformers can be slow and resource-intensive. This means that they can be expensive to run and that they may not be suitable for all applications. May not work well with all types of text, for example text that is very short or that contains a lot of technical jargon. Langchain text splitters, sentence transformers token text splitter. Detailed definition of the variable goes here. Components. Component 1. This text splitter uses sentence transformers to embed text and then uses a k-means clustering algorithm to group similar sentences together. It takes a text and breaks it down into a set of sentences. These sentences are then converted into numerical representations known as embeddings, which capture the meaning of each sentence. These embeddings are then clustered based on their similarity, grouping together sentences that express similar ideas. Component 2. It allows you to split a large document into smaller chunks, while preserving the semantic relationships between sentences. This is crucial for tasks like question answering and summarization, where maintaining the contextual flow of the text is important. For instance, if you have a long article about a specific topic, this text splitter can break it down into smaller paragraphs that still make sense together, preserving the overall meaning. Description of the architecture supporting the variable. This text splitter leverages the power of sentence embeddings to break down large text into semantically meaningful chunks. It utilizes sentence transformers to generate embeddings for sentences, which are then clustered based on similarity, forming coherent text segments. This approach allows for preserving the semantic context of the original text, leading to more meaningful and accurate splits. For example, a document discussing the history of artificial intelligence might be split into sections about its origins, key milestones, and future prospects, ensuring that each chunk maintains the flow of information. Explanation of the variable's role in the system. It plays a crucial role in breaking down large documents into manageable chunks that can be effectively processed by language models. By preserving semantic relationships, it ensures that the context and meaning of the original text are maintained during the splitting process. Consider a large research paper. This text splitter can break it into smaller, manageable sections while ensuring that the flow of ideas and arguments remains intact. This allows language models to understand the context and meaning of each chunk, leading to more accurate and informative analysis. Advantages. Preserves semantic relationships between sentences, leading to more contextually relevant splits. For example, in a product review, this text splitter could identify and group sentences related to specific product features, ensuring that each chunk focuses on a coherent aspect of the review. Offers flexibility in customizing splitting parameters such as chunk size and token overlap, providing greater control over the splitting process. For example, you can fine-tune the splitting process to generate chunks of a desired length, optimize for a specific task, or control the amount of overlap between adjacent chunks to ensure a smooth flow of information. Challenges. Computational overhead associated with embedding sentences, which can impact performance for very large documents. Embedding sentences requires significant computational resources, which can be a bottleneck when dealing with extremely large text corpora. Potential for inaccuracies in sentence embedding, which could lead to less optimal splits. The accuracy of the sentence embeddings can directly influence the quality of the splits. Errors in embedding can lead to incorrect grouping of sentences, resulting in splits that do not reflect the semantic structure of the original text. Langchain text splitters, sentence transformers token text splitter. A text splitter that uses sentence transformers for tokenization. Detailed definition of the variable goes here. Components. Component 1. Sentence transformers token text splitter is a text splitter that uses sentence transformers for tokenization and splitting. This text splitter utilizes a pre-trained sentence transformer model to transform sentences into numerical representations called embeddings. These embeddings capture the meaning and relationships between words within a sentence, enabling the splitter to identify natural sentence boundaries for splitting text. For instance, in a document with complex sentences, the sentence transformers token text splitter can accurately divide the text into smaller units, ensuring each unit is a complete and meaningful sentence. This enhances the quality and coherence of the output text chunks, making it ideal for tasks requiring precise sentence-level text processing. Component 2. It utilizes a pre-trained sentence transformer model to generate embeddings for each sentence and uses the embeddings to identify natural sentence boundaries for splitting text. A pre-trained sentence transformer model is essentially a machine learning model trained on a massive dataset of text and code, enabling it to understand the semantic relationships between words and sentences. By embedding sentences, the sentence transformers token text splitter can effectively differentiate between sentences, even when they contain similar words but convey different meanings. This capability is crucial for accurately splitting text based on semantic context, ensuring that each chunk retains the original meaning and flow of the text. For example, in a document about data analysis, this splitter can distinguish between sentences discussing different statistical methods, even if those sentences share common technical terms like regression or correlation, thereby preserving the logical flow of the document when splitting it into smaller units. Description of the architecture supporting the variable. Sentence transformers token text splitter is a text splitter that leverages sentence transformers for tokenization. It utilizes a pre-trained sentence transformer model to generate embeddings for each sentence and uses the embeddings to identify natural sentence boundaries for splitting text. The sentence transformers token text splitter relies on the power of sentence transformers, a type of deep learning model that learns to represent the meaning of sentences as numerical vectors. By feeding text into a pre-trained sentence transformer model, the splitter obtains embeddings for each sentence, allowing it to understand the semantic relationships between sentences. This process is analogous to converting a sentence into a mathematical representation, enabling the splitter to compare and contrast sentences based on their meaning, rather than simply their words. This capability is critical for accurate text splitting, especially when dealing with complex sentences or text with nuanced meaning. Explanation of the variable's role in the system. The sentence transformers token text splitter is a text splitter used to divide large blocks of text into smaller chunks, where each chunk is a coherent and meaningful unit. It enhances text processing efficiency by splitting text into manageable units. Sentence transformers token text splitter plays a crucial role in text processing by breaking down large chunks of text into smaller, manageable units. This is essential for various text-based tasks like document analysis, information retrieval, and machine translation. By splitting text into meaningful chunks, the Sentence Transformers Token Text Splitter facilitates efficient processing of the text without losing the original meaning or context. For example, in a document containing thousands of words, the splitter can break it down into smaller paragraphs, ensuring each paragraph is a coherent and self-contained unit. This makes it easier for downstream tasks like machine translation or question answering to process the text more effectively. Improved splitting accuracy based on sentence boundaries. Sentence Transformers Token Text Splitter utilizes sentence embeddings to understand the semantic context of each sentence, resulting in more accurate text splitting. This is especially beneficial when dealing with complex sentences or text with nuanced meaning, where simply relying on punctuation or word boundaries can lead to inaccurate splitting. For example, in a sentence with multiple clauses, the Sentence Transformers Token Text Splitter can identify the natural breaks between those clauses based on their semantic relationships, producing more accurate and meaningful chunks of text. Flexibility in choosing the desired sentence transformer model. Sentence Transformers Token Text Splitter offers flexibility in choosing a suitable sentence transformer model for specific use cases. There are numerous pre-trained sentence transformer models available, each tailored to different languages, domains, and task requirements. This flexibility allows users to choose the most appropriate model for their needs, ensuring optimal accuracy and performance for their text splitting tasks. For instance, for text in a specific domain like finance, a sentence transformer model trained on financial texts would be more effective than a general-purpose model. This allows users to customize their text splitting process to achieve the best results for their specific application. Computational cost associated with sentence embedding generation. Sentence Transformers Token Text Splitter involves generating embeddings for each sentence, which can be computationally expensive. This is particularly true for large text documents, where the number of sentences to be embedded is significant. However, advancements in hardware and optimization techniques are continuously reducing the computational cost associated with sentence embedding generation, making this approach more feasible for practical applications. Potential for splitting errors due to complex sentence structures or semantic ambiguity. While Sentence Transformers Token Text Splitter excels at identifying sentence boundaries based on semantic context, it can still face challenges with highly complex sentence structures or ambiguous language. These situations can lead to splitting errors where a sentence is incorrectly split or joined with another sentence. Researchers are continuously working on improving the accuracy of sentence embedding models, addressing these challenges and improving the reliability of text splitting based on semantic context. For example, in a sentence like "the cat sat on the mat," which was red and fluffy, the Sentence Transformers Token Text Splitter may struggle to determine the natural break between the clauses, leading to potential splitting errors. langchainai21 Chat Adapter Jamba Chat Completions Adapter. Definition: Jamba Chat Completions Adapter is a LangChain adapter for the ai21 Labs Jamba Chat API. It enables LangChain to interact with Jamba Chat for text generation. Components. Component 1. ai21 Labs Jamba Chat API. The ai21 Labs Jamba Chat Application Programming Interface is a service that provides the core text generation capabilities. It is a powerful tool that can be used to generate creative text content. translate languages, and answer questions based on provided context. Component 2. LangChain. LangChain provides a framework for integrating Jamba chat into larger language applications. It acts as an intermediary between the application and the Jamba chat API, simplifying the process of using the API. Architecture. Jamba Chat Completions Adapter acts as a bridge between LangChain and the Jamba Chat API. It translates LangChain prompts into requests that Jamba Chat understands, and then translates Jamba Chat responses back into a format that LangChain can use. Role. Jamba Chat Completions Adapter enables LangChain to leverage the capabilities of Jamba Chat for tasks such as generating creative text content, summarizing large amounts of text, translating languages, answering questions based on provided context. Advantages. Enhanced text generation capabilities through Jamba Chat. Jamba Chat provides advanced text generation capabilities, enabling LangChain to produce higher quality and more creative content. For instance, it can be used to write engaging stories, poems, articles, or even generate code in multiple programming languages. Seamless integration with LangChain framework. Jamba Chat Completions Adapter seamlessly integrates with the LangChain framework, making it easy to incorporate Jamba Chat's text generation capabilities into existing LangChain applications. This integration allows developers to easily leverage the power of Jamba Chat without needing to write complex code. Challenges. Jamba Chat API limitations may restrict certain LangChain features. The Jamba Chat application programming interface has limitations that may restrict the full functionality of certain LangChain features. These limitations could include constraints on the length of text that can be processed or types of tasks that can be performed. Potential for increased complexity due to API interactions. The interaction between LangChain and the Jamba Chat API can introduce additional complexity into the application. Developers need to manage the communication between the two systems, ensuring that prompts are correctly translated and responses are properly handled. This may involve handling errors, managing request limits, and optimizing performance. LangChain Text Splitters JSON. A structured overview, elaborated as text. LangChain text splitters are components within the LangChain library designed to break down large text inputs into smaller, manageable chunks for processing by language models (LLMs). This process of dividing text into smaller units is known as text splitting or text chunking. Text splitters essentially act as intermediaries between the input text and the language models, enabling the models to process information more efficiently by breaking down large text blocks into smaller, more manageable units. Component 1. Text splitters are the foundational components of LangChain's text processing pipeline. They act as the first line of defense, taking raw text input and transforming it into a format that is suitable for consumption by language models (LLMs). Think of them as the initial stage in a text processing assembly line, ensuring the text is prepped and ready for further analysis. Component 2. Character text splitters are a straightforward approach to text splitting, where the input text is divided into chunks of a specified character length. Imagine you have a long document, and you need to break it down into smaller sections for easier reading. A character text splitter can do this by dividing the text into chunks of 100 characters each. For example, Component 3. Word text splitters operate by segmenting the text based on word boundaries. In essence, they split the text into chunks based on the number of words contained within each chunk. For instance, If you have a large paragraph and want to split it into smaller sections containing 10 words each, a word text splitter can be used to accomplish this task. Component 4. Sentence text splitters leverage sentence boundaries to divide the text into chunks. They identify the natural breaks within the text, such as the end of a sentence, and split the text accordingly. This ensures that each chunk represents a complete thought or idea, improving the coherence and context of the resulting chunks. For example, imagine you have a long article, and you want to break it down into smaller segments for easier reading. A sentence text splitter can achieve this by separating the article into chunks that correspond to individual sentences. The architecture of LangChain text splitters revolves around defining strategies to divide text into manageable chunks. Each splitter implements a specific approach, such as splitting based on character count, word count, or sentence boundaries. Each splitter provides a specific approach to text chunking, and the choice of which splitter to use depends on the specific requirements of the task at hand. The architecture allows for flexibility and adaptability, catering to various text input formats and processing needs. Text splitters play a crucial role in LangChain by facilitating the efficient processing of large text inputs. They enable LLMs to handle and analyze large amounts of information by breaking it down into smaller, digestible units. Text splitters act as the key enablers for LLMs to effectively process large volumes of text. By splitting text into manageable chunks, they allow LLMs to focus on smaller units of information, improving their ability to process, understand, and generate meaningful responses. They are like the organizers of a large library, ensuring that the books are categorized and arranged in a way that makes them easily accessible and digestible. Enhanced language model processing capabilities. Text splitters empower language models to handle and analyze large amounts of text, leading to significant enhancements in processing capabilities. This is similar to how a powerful computer can handle complex calculations by breaking down large problems into smaller, more manageable ones. Improved memory management by breaking down large text inputs into smaller chunks. Text splitters facilitate efficient memory management for language models. This improves overall performance and avoids potential issues related to memory overflow or resource constraints. Control over chunk size. Text splitters offer granular control over the size of the generated chunks. Users can customize the chunk size based on the specific requirements of their task, ensuring optimal performance and output quality. Think of this like a recipe where you can adjust the portion size based on the number of servings you want to make. Streamlined text handling. Text splitters streamline text handling by breaking down complex text inputs into smaller, manageable chunks. This makes it easier for language models to process and understand the information. Maintaining coherence. One challenge associated with text splitters is ensuring that the resulting chunks maintain coherence and flow within the overall context of the original text. This is particularly relevant for text splitters that divide text based on word or character boundaries, as they may disrupt the natural flow of sentences or paragraphs. Preserving context. It is crucial that text splitters preserve the contextual information within each chunk. This is essential for maintaining the meaning and relevance of the text as a whole. Imagine a scenario where you are reading a story, and suddenly the text is abruptly split, leaving you unsure of the connection between the different sections. Text splitters need to avoid this by ensuring that the context is maintained throughout a text splitting process. Handling special characters. Text splitters must handle special characters effectively to avoid introducing errors or inconsistencies into the generated chunks. Special characters, such as punctuation marks, symbols, or line breaks, can be particularly challenging for text splitters, as they may disrupt the intended word or sentence boundaries. Optimization for different text formats. Text splitters should be optimized to handle various text formats effectively, including plain text, HTML, Markdown, and other common formats. This ensures that the text splitting process is adaptable and can handle diverse input formats. Think of this like a tool that can work with different types of files, such as documents, images, and videos. Langchain text splitters. Latex text splitter. Definition. Detailed definition of the latex text splitter component within the langchain framework. Components. Component 1. Langchain text splitters are designed to break down large pieces of text into smaller, more manageable chunks. This process makes it easier for language models to process and understand the text. Component 2. Latex text splitter is a specialized text splitter designed specifically to handle text written in the latex formatting language. Latex is commonly used in scientific and technical writing for its ability to produce high-quality documents with complex mathematical equations and layouts. Architecture. Description of the architecture behind latex text splitter. Explaining its approach to splitting latex documents. The architecture of latex text splitter is built upon the inherent structure of latex itself. Latex provides a way to define sections and subsections, allowing for logical organization of content within a document. Latex text splitter leverages this built-in structure to identify natural breakpoints for splitting the document into smaller chunks. For example, it might split a document at the beginning of each section or subsection, resulting in a set of smaller documents that each represent a distinct part of the original content. Role. Explanation of latex text splitter's role within the larger context of langchain. Latex text splitter plays a crucial role in making it possible for language models to effectively process and understand documents written in latex. Without this specialized text splitter, language models would struggle to parse and comprehend the complex structure and formatting found in latex documents. By breaking down these documents into smaller, more manageable units, latex text splitter allows language models to analyze and extract meaningful information from even the most complex latex content. This capability is particularly important in research, academia, and technical writing, where latex is widely used for its ability to precisely represent mathematical formulas, scientific notations, and other specialized content. Advantages. Latex text splitter is capable of accurately splitting latex documents into sections and subsections, ensuring that the resulting chunks maintain the logical organization and structure of the original document. This is essential for preserving the integrity and meaning of the content when it is processed by language models. Latex text splitter retains the original formatting of the latex document. This is crucial for maintaining the visual presentation and style of the content, ensuring that the resulting chunks are consistent with the original document's appearance. This is particularly important in fields where formatting plays a critical role, such as scientific research, where equations, tables, and figures are often carefully formatted to convey specific information. Challenges. Latex text splitter may encounter difficulties when dealing with complex latex structures such as nested environments. These structures can be challenging to parse and split accurately, potentially leading to errors or inconsistencies in the resulting chunks. This is a common challenge faced by any tool that attempts to process complex, structured data like LaTeX. LaTeX text splitter may not be able to handle all LaTeX commands correctly. This can result in errors during the splitting process, leading to incomplete or inaccurate chunks. The wide variety of LaTeX commands and their potential interactions make it challenging to ensure that all commands are handled correctly. This is an ongoing challenge for any tool that attempts to interpret and process the diverse syntax of a complex language like LaTeX. LangChain text splitter spacey summary. Nan. LangChain text splitter spacey leverages the power of spacey, a robust natural language processing NLP library, for efficient text splitting. It employs sparse-size advanced capabilities for tokenization and sentence segmentation, ensuring accurate division of text into manageable units. Component 1. Spacey is a Python library specializing in natural language processing (NLP). It provides a wide range of functionalities for tasks like tokenization, part-of-speech tagging, named entity recognition, and dependency parsing. Component 2. LangChain is a powerful framework designed for building and connecting different components within a language model application. It streamlines the development process by providing pre-built components and functionalities for tasks like text splitting, retrieval, and generation. LangChain text splitter spacey seamlessly integrates sparse-size NLP capabilities into the LangChain framework for efficient text splitting. It harnesses sparse-size advanced algorithms for tokenization and sentence segmentation, enabling the splitting of large documents into meaningful chunks. This integration allows for precise text processing, tailored to the specific requirements of downstream applications. LangChain text splitter spacey plays a crucial role in preparing large documents for efficient processing. It facilitates effective text splitting, breaking down extensive texts into smaller, more manageable units. This optimization enhances the performance of downstream tasks, enabling language models to process information efficiently and effectively. By utilizing sparse-size sophisticated sentence boundary detection algorithms, LangChain text splitter spacey significantly improves the accuracy of text splitting. This ensures that the generated text units correspond to natural language sentences, maintaining semantic coherence and readability. LangChain text splitter spacey leverages sparse-size robust NLP capabilities, specifically its advanced tokenization algorithms, to produce high-quality text splits. This ensures accurate identification of individual words and punctuation marks, resulting in precise and meaningful text units. The effectiveness of LangChain text splitter spacey is dependent on the availability of appropriate language models within the spacey library. If a language model for a specific language or domain is not available, the accuracy and effectiveness of text splitting may be compromised. While LangChain text splitter spacey excels in handling general text formats, it might require adjustments or fine-tuning for specific text formats or domain-specific terminologies. For example, splitting code snippets or technical documentation may necessitate specialized configurations to ensure accurate segmentation. LangChain AI21 contextual answers. Summary and key details with descriptions. LangChain AI21 contextual answers is a tool that allows you to ask questions based on a given context. It leverages AI21 Studio's powerful language models to understand the context and provide relevant answers. For instance, if you provide a document about a specific topic, LangChain AI21 contextual answers can answer questions about that topic based on the information in the document. Component 1. LangChain is a framework for building and deploying language model applications. It provides a modular and extensible way to create and integrate language models into various applications. You can use LangChain to connect to different language models, such as those from AI21 Studio or OpenAI, and build applications that can perform tasks like question answering, summarization, and text generation. Component 2. AI21 Studio is a platform for building and deploying AI applications, including language models. It offers a suite of tools and resources for developers to create and manage AI applications, including a powerful language model API. With AI21 Studio, you can access and use advanced language models to enhance your applications with natural language processing capabilities. Component 3. Contextual Answers is a feature that allows you to ask questions based on a given context. It provides a way to interact with language models in a way that considers the specific context of the input. For example, if you provide a document about a specific topic, contextual answers can answer questions about that topic based on the information in the document. The architecture involves using LangChain to interact with AI21 Studio's language models. LangChain provides the framework for building the application, while AI21 Studio provides the language model capabilities. Contextual Answers is a feature of AI21 Studio that allows you to ask questions based on a given context. For instance, a user can ask a question about a specific document, and LangChain will use the AI21 Studio language model to provide a relevant answer based on the context of the document. To provide relevant answers to questions based on a given context. For example, if you provide a document about a specific topic, LangChain AI21 contextual answers can answer questions about that topic based on the information in the document. Leverages AI21 Studio's powerful language models. These models are trained on massive datasets and have learned to understand and generate human-like text. This makes it possible for LangChain AI21 contextual answers to provide accurate and relevant answers. Provides accurate and relevant answers. By utilizing AI21 Studio's powerful language models, LangChain AI21 contextual answers can provide accurate and relevant answers to questions based on a given context. For example, if you provide a document about a specific topic, LangChain AI21 contextual answers can provide answers that are consistent with the information in the document. Easy to use and integrate. LangChain provides a simple and straightforward API for interacting with AI21 Studio's language models. This makes it easy for developers to integrate LangChain AI21 contextual answers into their applications. Requires access to AI21 Studio's application programming interface. This means that you need an API key from AI21 Studio in order to use LangChain AI21 contextual answers. May require fine-tuning for specific domains or use cases. While AI21 Studio's language models are powerful and versatile, they may not always be able to provide accurate and relevant answers for all domains and use cases. For example, if you are using LangChain AI21 contextual answers to answer questions about a highly technical or specialized topic, you may need to fine-tune the model or provide it with additional training data. LangChain Text Splitter using Spacie. None. LangChain's text splitter using Spacie is a component that leverages the powerful natural language Processing capabilities of SPACE to efficiently split text into manageable segments. Components. Component 1. LangChain's text splitter leverages SPACE's powerful natural language processing capabilities for efficient text splitting. It utilizes SPACE's pre-trained models to understand the linguistic structures of text, allowing for intelligent segmentation. This component leverages SPACE's capabilities for robust text processing. Component 2. SPACE's tokenization and sentence boundary detection algorithms provide precise text splitting. SPACE tokenizes text by breaking it down into individual words and punctuation marks, while its sentence boundary detection identifies the start and end of sentences. These algorithms ensure that text is split accurately, respecting the grammatical and semantic boundaries of the text. SPACE's dependency parsing and named entity recognition features enhance the text splitting process. SPACE's dependency parsing identifies grammatical relationships between words in a sentence, aiding in determining the correct boundaries for text splitting. Named entity recognition allows for the identification of specific entities, such as people, organizations, and locations, within text, enabling the splitter to maintain context even when breaking up sentences. LangChain's text splitter using SPACE enables effective text segmentation for large language models, enhancing processing and comprehension. This component plays a crucial role in preparing text for input into large language models (LLMs), ensuring that the input is divided into manageable segments while preserving the meaning and context of the original text. By splitting text into smaller, coherent units, the splitter optimizes the performance of LLMs, facilitating more efficient processing and comprehension. Precise text splitting based on linguistic structures. The splitter utilizes SPACE's linguistic knowledge to split text at appropriate points, ensuring that the resulting segments retain grammatical and semantic coherence. This approach improves the accuracy of text splitting compared to simpler methods, such as splitting based on fixed size chunks. Improved context retention within split text segments. By splitting text based on linguistic structures, the splitter preserves the context of the original text within each segment. This is crucial for LLMs, as they rely on the surrounding context to understand the meaning of individual words and phrases. Handling complex sentence structures and ambiguous boundaries. The splitter may face challenges when dealing with complex sentence structures, such as those containing multiple clauses or embedded phrases. Additionally, identifying the correct boundaries for splitting text can be ambiguous in certain cases, particularly when dealing with informal language or creative writing styles. Maintaining semantic coherence across split text segments. The splitter aims to split text while preserving the semantic coherence of the original text. However, certain cases may present challenges in maintaining this coherence, especially when dealing with long or complex text. Summary of LangChain AI21 Contextual Answers. AI21 Contextual Answers. None. This component represents the integration of the AI21 Studio application programming interface with LangChain, enabling the use of AI21's contextual understanding capabilities within LangChain applications. Component 1. The AI21 Studio Application Programming Interface. A collection of tools and resources provided by AI21 Labs. Facilitates interaction with AI21's language models. This interface enables developers to access powerful natural language processing capabilities through code, allowing them to incorporate AI21's technologies into their applications. Component 2. AI21 Contextual Answers is a specific component that leverages the AI21 Studio application programming interface to provide contextual understanding capabilities within LangChain. It facilitates tasks such as question answering and summarization, allowing users to query and analyze text data effectively. This component leverages AI21 Studio's powerful application programming interfaces for natural language processing tasks such as question answering and summarization. It integrates AI21's language models into LangChain applications, allowing for the seamless execution of natural language processing tasks. It acts as an interface to the AI21 Studio application programming interface, allowing users to integrate AI21's contextual understanding capabilities into their LangChain applications. The component serves as a bridge between LangChain and AI21 services, enabling LangChain users to access AI21's advanced natural language processing features without needing to directly interact with AI21's APIs. Access to AI21 Studio's advanced natural language processing models. This component provides access to the powerful language models developed by AI21 Labs, enabling users to leverage cutting-edge natural language processing capabilities within their LangChain applications. For example, users can use AI21's models to answer questions, summarize text, or generate creative content. Seamless integration with LangChain. This component seamlessly integrates with LangChain's framework, making it easy for users to incorporate AI21's capabilities into their existing LangChain applications. This integration streamlines the process of using AI21's features, allowing developers to focus on building their applications instead of handling complex API interactions. Potential application programming interface rate limits or cost considerations. Using AI21 Studio's application programming interfaces may involve rate limits, restricting the number of requests that can be made within a specific time frame. Additionally, there may be cost considerations associated with using AI21 services, requiring users to manage their usage and costs effectively. Dependence on AI21 Studio's services. This component relies on AI21 Studio's services to function. If AI21 Studio's services become unavailable, this component will be unable to operate, highlighting the importance of ensuring service stability and redundancy in application development. The seamless integration of ai21base models capabilities into LangChain projects. Simplifying the development process. Developers can easily access and utilize the model's functionality without needing to delve into its intricate internal workings. Advantage 2. Enhanced functionality. The ability to access a broad array of text-based tasks powered by the AI21 base model. This integration opens up a world of possibilities for developers, enabling them to build applications that leverage the model's capabilities for text generation, translation, summarization, question answering, and more. Advantage 3. Simplified development. The use of LangChain's intuitive interfaces and functionalities, which streamline the development process. This allows developers to focus on building their applications without getting bogged down in complex configurations or integrations. Challenges. Challenge 1. Limited control. The limited control over the AI21 base model's internal workings due to LangChain's wrapper functionality. While LangChain provides easy access to the model, it might not offer the granular control that some developers might require for fine-tuning a model's behavior or understanding its internal mechanisms. Challenge 2. Dependency on AI21 Studio. Reliance on AI21 Studio's infrastructure for accessing and utilizing AI21 base model. This dependency means that developers are reliant on the availability and stability of AI21 Studio's services, which could potentially impact the functionality or performance of their applications. LangChain AI21 Embeddings. AI21 Embeddings Summary. None. Detailed definition of the variable LangChain AI21 Embeddings. AI21 Embeddings Summary goes here. Components. Component 1. AI21 Labs Embedding Service is a service provided by AI21 Labs that allows users to generate text embeddings. Embeddings are numerical representations of text that capture semantic meaning and relationships between words. Component 2. AI21 Studio's Embedding Application Programming Interface (API) is a powerful tool for creating and managing embeddings. It uses advanced language models from AI21 Studio to understand the nuances of text and generate embeddings that are accurate and informative. Description of the architecture supporting the variable LangChain AI21 Embeddings. AI21 Embeddings Summary. AI21 Studio's powerful language models are used for embedding text. This architecture ensures that the embeddings generated are accurate and informative, leveraging the sophisticated capabilities of AI21 Studio's language models. Explanation of the variable's role in the system. The LangChain AI21 Embeddings. AI21 Embeddings Summary variable provides a way to generate embeddings for text using AI21 Studio's Embedding Application Programming Interface (API), which can be used for various tasks like similarity search, clustering, and classification. For example, in a recommendation system, the embeddings can be used to identify items that are similar to those a user has previously interacted with. Leverages AI21 Studio's advanced language models for high-quality embeddings. This ensures that the embeddings generated are accurate and informative, reflecting the nuances of the text being embedded. Offers a convenient integration with LangChain, simplifying embedding operations. The variable seamlessly integrates with LangChain, enabling users to easily incorporate embedding capabilities into their LangChain applications, without needing to manage the underlying complexities of the AI21 Studio embedding application. Programming Interface (API) may have limitations in terms of embedding length or specific model capabilities. There may be limitations on the length of text that can be embedded, and the specific capabilities of the AI21 Studio language model used for embedding might impact the quality of the embeddings. Requires an API key and potential costs associated with AI21 Studio's service. Using AI21 Studio's embedding service requires an application programming interface API key, and there may be associated costs depending on usage. LangChain AI21 Embeddings. A detailed explanation of LangChain's AI21 embeddings. Detailed definition of the variable goes here. Components. Component 1. A LangChain component that allows you to use AI21 Studio's embedding models to create vector representations of text. This means the component translates text into numerical data that captures the meaning and relationships between words. For example, it could represent the sentence "The cat sat on the mat" as a set of numbers that capture the relationship between the words cat, sat, on, and mat. Component 2. This component can be used in a variety of LangChain applications, such as semantic search, question answering, and text summarization. For example, in semantic search, You could use it to find documents similar to a query based on the meaning of the words, not just their exact appearance. Description of the architecture supporting the variable. The AI21 embeddings component in LangChain leverages AI21 Studio's powerful embedding models. These models, trained on a vast corpus of text data, produce high-quality vector representations. This component then seamlessly integrates these embeddings into LangChain's workflow for diverse tasks. The component essentially acts as a bridge between LangChain's capabilities and the advanced embedding models offered by AI21 Studio. Explanation of the variable's role in the system. The role of LangChain's AI21 embeddings component is to provide a means to access and utilize AI21 Studio's embedding capabilities. This allows you to seamlessly integrate AI21 Studio's advanced embedding models into your LangChain applications for tasks like similarity search, document retrieval, and understanding the meaning of text. For instance, if you are building a chatbot, you could use this component to understand the meaning of user input and generate more relevant responses. High-quality embeddings. AI21 Studio's embedding models are known for their quality, leading to more accurate and relevant results in applications like semantic search. For instance, when searching for documents related to a particular topic, the component's high-quality embeddings can ensure that only truly relevant documents are retrieved. Easy integration. The component provides a simple interface for integrating AI21 embeddings into LangChain, making it straightforward to utilize their capabilities. This makes it easier for developers to add the powerful AI21 Studio embeddings to their LangChain applications without having to write complex code. Cost. Using AI21 Studio's embeddings may incur costs depending on usage. This is because AI21 Studio's embedding models are a commercial product, and their use may require a subscription or pay-per-use model. Limited customization. The component primarily provides access to AI21 Studio's pre-trained models, limiting customization options. While this makes it easy to get started, it might not be suitable for applications requiring highly specialized embedding models. For example, if you need to fine-tune the embedding model to a specific domain, you may need to explore other options. LangChain AI21 Chat Adapter. Jamba Chat Completions Adapter. Definition: a LangChain adapter for integrating with the AI21 Jamba Chat application programming interface. Components. Component 1. LangChain adapter for enabling the integration of AI21 Jamba Chat with LangChain for conversational AI tasks. Component 2. AI21 Jamba Chat application programming interface for natural language understanding and generation. Capabilities. Architecture. The adapter uses the LangChain framework to interact with the AI21 Jamba Chat application programming interface for conversational AI tasks. This allows developers to seamlessly integrate Jamba Chat's conversational abilities into their LangChain applications. Role. Enables the integration of Jamba Chat into LangChain workflows, facilitating conversational interactions with AI21's language models. The adapter allows users to leverage Jamba Chat's conversational capabilities within LangChain applications, enabling the creation of AI-powered chatbots and conversational systems. Advantages. Simplified integration with Jamba Chat, allowing developers to easily integrate Jamba Chat's conversational abilities into their LangChain applications without having to write complex integration code. Leverages LangChain's capabilities for building conversational applications. allowing developers to build sophisticated conversational AI applications that utilize the power of Jamba Chat and the flexibility of LangChain. Challenges. Potential for application programming interface rate limiting, which can occur when too many requests are made to the Jamba Chat application programming interface in a short period of time. This can lead to delays or errors in processing requests. Compatibility with specific Jamba Chat model versions. As new versions of Jamba Chat models may have different functionalities or API requirements, this can require updates to the adapter to ensure compatibility. LangChain AI21 LLMS integration. A comprehensive overview. This integration enables the use of AI21 Studio's powerful language models within the LangChain framework. LangChain is an open-source framework for building and deploying applications powered by large language models (LLMs). AI21 Studio is a platform that offers a suite of advanced LLMs, including Jurassic 1 Jumbo, known for their superior performance in various tasks. This integration bridges the gap between LangChain's application development capabilities and AI21 Studio's cutting-edge language models, enabling developers to seamlessly integrate advanced AI capabilities into their projects. Component 1. LangChain is an open-source framework for building and deploying applications powered by large language models (LLMs). It provides a modular and extensible architecture that simplifies the process of building complex AI-powered applications. For instance, it allows users to easily chain together different LLM models, pre-process data, and post-process outputs. Component 2. AI21 Studio is a platform offering a suite of advanced LLMs, known for their superior performance in various tasks. These LLMs are trained on massive datasets and can perform tasks such as text generation, translation, summarization, question answering, and code generation. One prominent example is Jurassic 1 Jumbo, renowned for its capabilities in natural language understanding and generation. The integration is built upon the principles of modularity and extensibility, allowing users to easily connect AI21 Studio's LLMs with LangChain's powerful tools and functionalities. This seamless integration allows users to leverage the strengths of both platforms, fostering a collaborative environment for developing AI-powered solutions. For example, users can easily integrate a Jurassic 1 Jumbo model into a LangChain application for tasks like text summarization or question answering. This integration bridges the gap between LangChain's application development capabilities and AI21 Studio's cutting-edge language models, enabling developers to seamlessly integrate advanced AI capabilities into their projects. This integration is crucial for developers who seek to leverage the power of advanced LLMs within their applications, simplifying the process of building sophisticated AI-powered solutions. Advantage 1. Access to a diverse range of AI21 Studio LLMs, catering to different application requirements. This integration provides developers with access to a wide range of advanced AI models, allowing them to choose the best model for their specific application needs. For example, a developer working on a chatbot application can select a model specializing in dialogue generation, while another developer working on a document summarization application can choose a model designed for this specific task. Advantage 2. Leverage LangChain's robust features for chain building, prompt engineering, and result processing. LangChain provides a comprehensive set of tools for working with LLMs, including capabilities for building chains of models, crafting effective prompts, and processing the outputs generated by these models. This allows developers to build sophisticated applications that leverage the full potential of AI models, maximizing their efficiency and effectiveness. Challenge 1. Ensuring seamless communication and data exchange between LangChain and AI21 Studio. This involves establishing an effective and reliable communication channel between the two platforms, allowing for the smooth transfer of data and commands. This may require careful consideration of data formats, API protocols, and error handling mechanisms to ensure that the interaction between LangChain and AI21 Studio is seamless and efficient. Challenge 2. Optimizing performance and resource usage when interacting with powerful AI21 Studio LLMs. These models require significant computational resources and careful optimization to ensure that they can perform effectively within a given environment. This involves strategies like using efficient data structures, optimizing code for performance, and managing memory usage effectively. LangChain AI21 embeddings. AI21 embeddings. None. Detailed definition of the AI21 embeddings variable, which is a LangChain integration with AI21 Studio's embedding model. This integration allows users to leverage AI21 Studio's powerful embedding capabilities within a LangChain framework. Components. Component 1. The AI21 Studio embedding model is a pre-trained machine learning model that can generate vector representations of text. These vectors capture the semantic meaning of the text, allowing for tasks such as similarity search, clustering, and classification. Component 2. The LangChain integration provides a convenient way to access and utilize the AI21 Studio embedding model within the LangChain ecosystem. LangChain is a framework for building and deploying language applications, and its integration with AI21 Studio's embedding model simplifies the process of embedding text within LangChain applications. Description of the architecture supporting the AI21 embeddings variable. The AI21 embeddings variable leverages the AI21 Studio embedding application programming interface API to generate text embeddings. The user interacts with the AI21 embeddings variable through the LangChain interface, sending text to the API. The API then processes the text and returns a vector representation, which can be used by downstream LangChain applications for various tasks. Explanation of the AI21 embeddings variable's role in the system. The AI21 embeddings variable plays a crucial role in enabling the utilization of AI21 Studio's embedding capabilities within LangChain applications. This integration enables downstream applications to perform tasks like semantic search, text clustering, and classification based on the semantic similarity between text data points. High-quality embeddings generated by the AI21 Studio model provide accurate and semantically meaningful representations of text, enhancing the performance of downstream applications. Easy integration with LangChain simplifies the process of embedding text within LangChain applications, allowing users to easily leverage AI21 Studio's capabilities without needing to write complex code. Limited customization options for the embedding model are available, as the AI21 embeddings variable relies on the pre-trained AI21 Studio embedding model. This restricts users' ability to tailor the embedding process to specific requirements. Cost associated with using the AI21 Studio embedding application programming interface API is a significant consideration, especially for projects with high usage volume.